Hey everybody, it's Mr. Conan here, and today we're going to go over another method of translating a standard form quadratic into a vertex form quadratic. Again, we can write our vertex form quadratic as y equals a times x minus h squared plus k, where my vertex is written as hk. So, the second method is called completing the square. What we're going to do is we're going to take this quadratic y equals x squared plus 4x plus 3, and we're going to manipulate it algebraically to get me my vertex form quadratic. Now this way is a little bit more complicated than just finding the vertex and plugging in points, so bear with me through this video. So first thing I'm going to do is I'm going to get the x terms on the right side to be alone. To do that, I have to subtract 3 from both sides. I end up with y minus 3 equals x squared plus 4x. After I've moved the 3 to the left side, what I'm going to do is factor out the a value from the right side, from both terms. Now because my a value on the right side is 1, I can rewrite this equation as y minus 3 equals 1 times x squared plus 4x. While this doesn't really help us out in this situation just because our a equals 1, in situations where a is greater than 1, this is a necessary step to make sure that both sides of the equation are getting added the same thing. We want to make sure that both sides are equal. So, what we're going to do now, since we have our quadratic on the right, is we're going to find a value that makes a perfect square quadratic. Now, what I mean by a perfect square quadratic is I can write the factors of this. X squared plus 4x plus something is the same thing as x plus something and x plus the same something. So, if I do something to one side, I have to do it to the other side as well. So, I can write this next line as y minus 3 plus 1 times something, that's in the brackets, equals 1 times x squared plus 4x plus that same something. Now, you might be asking, how do I find this something? Well, I'm going to tell you. Our brackets are equal to our b value divided by 2, since we want to find two values that add up to give me b, squared, because I want this to be a perfect square. So when I plug in my b value from the original equation, which was, since I had my 4x term, my b value is going to be 4. I have the something equals 4 over 2 squared. When I simplify this down, I have something equals 2 squared, because 4 over 2 is 2. And then 2 times 2 gives me 4. So I can replace whatever was my brackets with the term 4. So I have y minus 3 plus 1 times 4 equals 1 times x squared plus 4x plus 4. Now what I'm going to do is I'm going to simplify both sides. So on the left, I need to combine like terms. I have y minus 3 plus 4 equals 1 times x plus 2, x plus 2. Now, what's important to realize here is that x plus 2 times x plus 2 is the factors of my x squared plus 4x plus 4 quadratic. Because when I multiply x plus 2 times x plus 2, I get that quadratic. Now, if I combine like terms on the left, I get y plus 1, because minus 3 plus 4 equals a positive 1. And on the right side, I have 1 times x plus 2 squared. Because I'm multiplying the same term twice, the x plus 2 and the x plus 2, I can rewrite that as x plus 2 squared. Now finally, I am so close to getting this to my vertex form. All I need to do is isolate my y term. I want to get that y alone. The way I'm going to do that is by subtracting 1 on both sides. So once I subtract 1 and move that plus 1 away, I have y equals 1 times x plus 2 squared minus 1. Oh, excuse me for a second. Boom, squared. So this would be my vertex form of the equation. And as you notice, I get the exact same answer as if I were solving using the vertex method.